Okay, so it's when t is not initially the time. This is the model for the population, and we can start our time in 1900, can't we? So if we set the time to be 0, then this would be 20, 40, 60, 60, 80 and 100, which are user friendly, and it'll start from t equals 0, because that's when it's asking for the value of n0 when t is 0. Presumably this value is the one that the question seems to want to ask. So the population then, which is n, is equal to, we don't know, 1357. So let's just put these down again. 1228, 1111, 1005, and 910. So let's take logs here. Log to base e, natural logarithms. It will be ln of n naught times you add, so it's plus, but the minus rt comes down, ln of e. So ln of n is equal to minus r times t plus ln n naught. That's because log e is 1. Okay, so we need to plot t against ln. So t on the x-axis. Let's write that down again. Doesn't take a moment to do. And then ln. So we want ln of the population size. We don't know it here, but we know ln of 1357. ln of 1357. 7.21. And then ln of 1228. 7.11. And ln of 1111. 7.01. And ln of 1005. 6.91. And ln of 910. 6.81. So now we need to draw the graph. Here, let's draw some axes. Here. So this would be t, this is ln. Here. The t would be going to 100, so 20, 40, 60, 80, 100. And it goes up to 7 point something, so 1, 2, 3, 4, 5, 6, 7. Okay. 7.21 at 0, so that would be here. Then 7.11, 20 rather, not at 0. 7.11, 7.21 rather, and then 7.11, so it's going to be a fairly flat line, isn't it? Difficult to draw. 7.01 at 60, ooh, that's just small. And then 6.91 at 80. Would have been better to have drawn a different scale, really, wouldn't it? Start at 6 or something, or even 5 or 6, and just do a bigger scale. And then 6.81 at 100, but I've done it now. So it's a really flat line, which I've probably drawn very badly. So I'm going to try and draw it now. Okay, there's the line. Okay, I'm going to draw a triangle underneath it now. It doesn't come down much in 100, so I'll just draw it along to 100 here. See what it comes out at. So I'm going to try and go across. This triangle is pretty awful, actually, because at 100 that value is 6.81, and I reckon it's about 7.3 here. So I reckon the vertical height is going from 7.3, looking at the data, to about 6.8. If I'd have drawn this accurately, it would have gone down 0.5 then, and it comes across 100. So that's the slope, really. this is much more accurate here, which is minus 0.005 is m, and m corresponds to, if you look at it, y equals mx plus c, so m is minus r. M equals minus r, so minus r then equals minus 0.005, so r equals 0.005 then. So there's r. Now, the other thing we need is log n naught, which is the intercept. ln n naught is equal to, and I reckon it's 7.3 it started at, 7.3. So n naught is equal to e to the 7.3 n naught e to the 7.3 1480 1480. So there's n naught. That's what was asked for the population, which is in the notes. The answer in the book is 1500, so that's quite good. Okay, so, and also now down to a population of 800, wasn't it? What is the time? N equals n naught. N equals n naught. E to the minus r. 05t. So when does it go down to about 800? E to the minus 0.005t then is equal to 800 over 1480. 80 over 148 is 40 over 74, which is 20 over 37, isn't it? Okay, good. So therefore the time minus 0.005t is equal to, take logs, ln 20 over 37, so t will equal minus 1 over the 0.005, just put the minus up above, ln of 20 over 37, so 1 divided by 0.005 times natural logarithm of 20 divided by 37 equals minus, but there's a minus here, so it's 123, 123 to the nearest unit. We started at 1900, so that would mean time in years is equal to 1900 and 123 is 2023, and the notes had the solution at 2025.